April 29, 1945. The Harz Mountains, Central Germany. The Reich has 8 days left to live, but no one in the 104th Infantry Division knows that yet. What they know is this. Intelligence says there's something under the Nordhausen complex that matters more than territory. Not gold, not prisoners. Paper. The problem isn't the enemy. Most of the SS garrison fled west 3 days ago, trying to surrender to anyone but the Russians. The problem is that 60 feet of reinforced concrete just collapsed into itself during an RAF bombing run 2 weeks prior. And beneath it, according to a defector's sketch, is a records vault the size of a high school gymnasium. A vault that contains every schematic, test report, and production estimate for weapons systems the Allies didn't know existed until soldiers started dying from them. Before we go further, subscribe now, because every week we dig into the buried missions, the machines that never made it into your textbook, and the engineers who had to improvise history with a flashlight and a shovel. The 104th had been fighting since Normandy. They were tired, efficient, and very good at knowing when something smelled wrong. This smelled wrong. The Nordhausen site wasn't just another factory. It was part of Mittelwerk, an underground labor camp and production facility carved into the mountains by 20,000 slaves, most of whom didn't survive to see spring. The Allies knew the Germans had been building V-2 rockets there. What they didn't know was what else had been designed in the deeper levels, the ones not on any captured map. The commanding engineer was a captain named Raymond Mills, 31 years old, a civil engineer from Pittsburgh, who'd spent the last year blowing up bridges and clearing minefields under fire. He wasn't trained for archaeology. He was trained to move dirt fast and not die doing it. But when he stood at the edge of the crater on that cold morning and looked down into the torn earth, he understood immediately that this wasn't a combat engineering problem. It was a retrieval problem. And retrieval problems in a collapsing enemy state, with the Red Army closing from the east, don't get second chances. The collapse had created a funnel of shattered concrete, twisted rebar, and clay. Somewhere beneath it was a steel door. The defector, a German engineer who'd walked into American lines with frostbite and a hand-drawn map, said the vault was airtight, fireproof, and locked with a mechanical seal that required 2 keys and a combination. He also said it was designed to flood if tampered with. Salt water, pumped from reservoirs built into the surrounding rock. The kind of trap you set when you know you're losing and you want to make sure no one gets your work. Mills assembled a crew, 12 men from the 329th Engineer Combat Battalion, 2 intelligence officers who spoke German, a Navy demolitions expert on loan from a minesweeper group that had nothing left to sweep, and a Belgian civilian named Anton Cleary, who claimed to have worked as a mining engineer before the war. No one asked what he'd been doing during the occupation. No one cared. He knew how to shore up a tunnel, and that was worth more than a clean resume. They started digging on April 30th, the day Hitler killed himself in Berlin. No one knew that either. The first 72 hours were slow, methodical, and terrifying. The rubble wasn't stable. Every time they pulled a slab of concrete free, something else shifted. Twice they had to evacuate the pit because the walls started groaning. Mills brought in timber from a demolished rail yard, massive oak beams that had once held up a freight platform, and they used them to brace the dig site, building a skeleton of wood inside the wound of concrete. It looked medieval. It worked. By May 2nd, they'd cleared enough debris to see the door. It was massive, 8 feet tall, 4 inches of solid steel, painted feldgrau and streaked with rust from groundwater seeping through the ceiling. The locking mechanism was German engineering at its most paranoid. 3 separate bolt systems, each controlled by a different dial. The defector's diagram showed the combination, but Mills didn't trust it. The Germans had a habit of booby-trapping their own documentation. If the combination was wrong, or if the door sensed forced entry, the vault would flood in under 4 minutes. The intelligence officers wanted to try the combination. Mills overruled them. He ordered his men to drill an inspection hole through the steel frame beside the door, just wide enough to snake a flashlight and a mirror through. It took 6 hours with a diamond-tipped bit salvaged from a Luftwaffe machine shop in town. When the bit finally punched through, they heard it, the hiss of equalized pressure, and then the smell. Dry air, old ink, machine oil, paper. The vault was intact. Mills gave the order. They tried the combination. The first dial spun smooth. The second caught, then released. The third didn't move. The defector started sweating, muttering in German that he'd written it down correctly. that he'd seen the chief engineer open it a dozen times. The Navy demo man knelt beside the door, pressed his ear to the steel, and listened. Then he stood up, walked over to the dial, and hit it with the butt of his rifle. Something inside clicked. The dial turned. The door opened. No water came. No explosion. Just the exhale of stale air that had been locked away since March. Inside was a room 30 meters long, lit only by their flashlights. The walls were lined floor to ceiling with filing cabinets, blueprint tubes, and wooden crates stenciled with Gothic script. In the center of the room were 3 drafting tables still covered with unfinished drawings. On one table, a cutaway schematic of a rocket engine with staging mechanisms the Allies wouldn't develop for another decade. On another, plans for a swept-wing jet aircraft with range estimates that didn't make sense until someone realized the fuel system was designed around synthetic compounds no one in the West was producing yet. And in the back, locked inside a glass case like a museum exhibit, was a scale model of a bunker-busting bomb with a shape that looked wrong, too long, too narrow, with fins that angled back in a way that seemed aerodynamically impossible. Beside it, a typewritten report in German. The intelligence officer translated the title aloud: Penetration Dynamics of Hypersonic Ordnance in Reinforced Subterranean Structures. The date on the report was January 1945, 4 months ago. The war was already lost, and they were still designing weapons for wars that hadn't been fought yet. Mills ordered everything photographed, cataloged, and crated. They worked in shifts, 20 hours a day, sleeping in the tunnel when they had to. The Soviets were now 48 hours out, maybe less. American command sent word: extract what you can, destroy the rest, and get out. But Mills didn't destroy anything. He couldn't. This wasn't just intelligence. This was the archive of a war machine that had been thinking 10 years ahead even as it collapsed. On May 6th, they hauled the last crate out of the vault. 218 boxes of documents, 1,600 blueprints, 43 prototype models, 12 filing cabinets full of test data that would take Allied scientists 5 years to fully decode. They loaded it onto 3 trucks, covered it with tarps, and drove west through the night, past columns of surrendering Wehrmacht soldiers who didn't even look up. The bunker was resealed and listed as cleared in the after-action report. The Soviets occupied Nordhausen on May 8th, the day Germany surrendered. They found the factory. They found the tunnels. They didn't find the vault. Mills had collapsed the entrance behind him with enough rubble that it looked like it had always been there. Most of the documents were classified for 30 years. Some are still classified, but the ones that were released changed everything. The swept wing. Jet research informed the F-86 Sabre, the plane that dominated the skies over Korea. The rocket staging data fed directly into the Redstone and Atlas programs, the missiles that would carry America's first astronauts. The bunker buster blueprints became the basis for penetrator munitions still in use today, designed to crack enemy command centers buried under mountains, just like the one Mills had dug into. And the engineers, the ones who spent 6 days in a collapsing hole with flashlights and crowbars, racing against the Red Army and the possibility that the whole thing might flood or blow. None of them got medals. They got a commendation buried in a file cabinet in the National Archives. Mills went back to Pittsburgh, built highways, died in 1982. His obituary didn't mention Germany, but in 1947, when the Air Force was trying to figure out how to build a jet that could break the sound barrier, and in 1961, when NASA was building a rocket to reach the moon, and in 1991, when mission planners were choosing bombs to crack Saddam's bunkers in Baghdad, they were all reading blueprints that had been locked in the dark beneath a mountain, waiting for someone desperate enough to dig them out. The intelligence officers who'd gone into the vault with Mills wrote a joint report 3 weeks after the war ended. It was 8 pages, single-spaced, classified secret, and routed to the Pentagon, the Office of Strategic Services, and a newly formed technical intelligence unit that didn't have a name yet. The report's conclusion was 1 sentence long. The enemy was not defeated before he could finish his research. He was defeated while still accelerating it. That line haunted American military planning for the next decade, because the implication was clear: if the war had lasted another year, if Germany had held the Ruhr for 6 more months, if the bombing campaigns hadn't shattered their production lines and forced them underground, what comes out of that vault isn't an archive. It's a deployed arsenal, The documents themselves told a story that no one wanted to hear in the spring of 1945, when everyone just wanted the war to be over. They told the story of a weapons development program that had bifurcated in late 1943 into two parallel tracks. Track 1, build what we can build now, with the materials and labor we have, to keep fighting today. That was the V-2, the ME-262, the Type 91 U-boat, all desperate, brilliant, too-late solutions to problems the Allies had already solved with mass production. Track 2, design what we'll need if this war becomes the next war, if it goes underground, if it goes atomic, if the enemy has jets and we need something faster. Track 2 was the vault. The swept-wing research wasn't just theoretical. There were wind tunnel test results, strain gauge readings from wooden models flown at transonic speeds in a vertical tunnel facility that Allied intelligence didn't know existed until they found the data. The lead engineer was a man named Heinrich Blau, a Bavarian aerodynamicist who'd worked for Messerschmitt before the war and who'd been transferred to the Nordhausen site in 1944 with instructions to solve the compressibility problem. The problem being, when you push an aircraft close to the speed of sound, the air stops, behaving like air, and starts behaving like a wall. Straight wings shake themselves apart. Blau's solution was elegant and terrifying. Sweep the wings back, let the airflow hit them at an angle, delay the shockwave formation. He didn't have time to build a full prototype, but he had time to prove it would work. His notes were meticulous, page after page of calculations, some done by hand, some run through a mechanical computer. A Zuse Z4, one of the only working programmable machines in Germany at the time. There were failure logs, 3 models destroyed in testing, 1 engineer killed when a wing spar snapped during a high-speed ground test, and there were projections. If you built this airframe with these engines, at this weight, you'd have an interceptor capable of 1,080 kilometers per hour in level flight, faster than anything the Allies had on the drawing board in 1945, faster than anything anyone had until the F-86 flew in 1947, using wings that looked almost identical to Blau's drawings. No one at North American Aviation ever admitted they'd seen the Nordhausen documents, but the timeline is hard to ignore. The first F-86 design proposals were submitted in late 1945. The media swept-wing configuration appeared in revisions dated early 1946, after technical intelligence reports from Germany had been disseminated to cleared contractors. The Air Force called it convergent evolution. The engineers called it a gift. Blau survived the war. He surrendered to British forces in May, was interned, then quietly recruited into Operation Paperclip, the program that brought German scientists to America in exchange for immunity and a paycheck. He spent the 1950s working for NACA, the predecessor to NASA, designing high-speed research aircraft. He never talked about Nordhausen. When journalists asked, he'd say he'd worked on propulsion studies. When they pressed, he'd walk away. He died in 1979 in a suburb of Pasadena, and his obituary in the Pasadena Star-News listed him as a retired aerospace consultant. It didn't mention that he'd been part of a team that had nearly given the Luftwaffe air superiority in a war that never happened. The rocket staging documents were even more unsettling. They weren't just refinements of the V-2. They were plans for a 3-stage orbital vehicle designed to carry a payload of 800 kilograms to an altitude of 300 kilometers, low Earth orbit by any definition. The engineering was incomplete. The Germans didn't have guidance systems precise enough to make it work, didn't have heat-resistant materials for re-entry, didn't have the fuel production capacity to launch more than a handful. But the concept was sound, and the math was right. Werner von Braun saw those documents in the summer of 1945, after he'd surrendered to the Americans with most of his engineering team. He'd already been working on staged rockets at Peenemünde, but the Nordhausen papers included test data he hadn't seen, combustion stability, readings from engine clusters, structural load analysis from separation events, fuel mixture ratios optimized for altitude. Von Braun's team had been experimenting. The Nordhausen group had been engineering. Some of those engineers didn't make it out. They were slave laborers, French, Polish, Russian, prisoners, who'd been forced to do the calculations, draw the schematics, check the math on systems designed to kill their own countries. A few survived the war and testified at the Nuremberg trials. One, a Polish mathematician named Jerzy Kawecki, described working 18-hour shifts in an unheated subterranean office using a slide rule and graph paper to optimize the fuel-to-weight ratios for a rocket that would never be built. When asked why he didn't sabotage the work, he said, "Because they told us if the calculations were wrong, they would test the rocket anyway, with us strapped to it." The bunker buster designs were the most immediately useful and the most legally complicated. They were plans for bombs designed to penetrate deep underground and detonate in a delayed sequence. First a shaped charge to crack the surface, then a secondary warhead to punch through hardened layers, then a main charge timed to explode after the weapon had burrowed as deep as physics would allow. The concept wasn't new. The British had been working on similar weapons, but the German designs had solved problems the Allies were still struggling with: how to keep the bomb stable during penetration, how to prevent premature detonation from impact shock, how to fuse the warhead so it would wait until it was deep enough to matter. The designs were used, not immediately. There was no need in 1945, with Germany flattened and Japan about to surrender. But later, in Korea, when the Air Force needed to crack tunnels in the mountains north of the 38th parallel, in Vietnam, when bunker complexes in the Central Highlands required penetrators that could go through 10 meters of earth and reinforced concrete, in Iraq in 1991 and 2003, when hardened command bunkers were hit with GBU-28 bombs, 5,000-pound weapons with a shape and a fusing mechanism that descended directly from papers pulled out of a flooded Nazi vault. Mills never knew. He'd done his job, filed his report, and gone home. But analysts at Air Force Intelligence knew. In a 1978 internal memo, declassified in 2002, A.E. targeting officer noted that current deep penetration munitions owe more to German research recovered in 1945 than to any Allied development program of the same period. The memo was written in response to a congressional inquiry about why the U.S. was still using bomb designs that were over 30 years old. The answer, unspoken but clear in the subtext, was because they were 30 years ahead when we found them. By the 1980s, the Nordhausen archive had been digitized, cross-referenced, and integrated into the Defense Technical Information Center database. Engineers working on modern projects, stealth aircraft, hypersonic missiles, bunker-penetrating munitions, could search the database and pull up documents that had been typed on manual typewriters in a mountain in 1944. Some of the drawings were still clearer, more detailed, than anything produced with early CAD software. The Germans had been working with pencils and slide rules, but they'd been working with the precision of people who knew there wouldn't be a second draft, and some of the designs were never used. The hypersonic ordnance study, the one Mills had found in the glass case, described a bomb that would be dropped from high altitude, accelerate under rocket power to several times the speed of sound, and hit its target with purely kinetic energy. No explosive, just mass and velocity. The math showed it would work. The engineering showed it could be built. But the cost and complexity were prohibitive in 1945 and remained prohibitive for decades. It wasn't until the 2000s when the U.S. started developing prompt global strike weapons, hypersonic missiles that could hit any target on Earth in under an hour, that engineers went back to those papers and realized the Germans had sketched the concept 60 years earlier. There's a file in the National Archives, box number RG319, entry 82, folder 47. It contains the original defector map, the one that led Mills to the vault. The map is drawn in blue pencil on the back of a requisition form for winter coats. The defector's name is redacted. His fate is redacted. But someone, probably Mills, wrote a note in the margin in fading ink. He said they were building weapons for a war they knew they'd lost. I didn't understand that until I saw what was inside. They weren't building for this war. They were building for ours. The bunker at Nordhausen was dynamited by the Soviets in 1947. The tunnels were sealed. The factory was dismantled. The mountain was left alone. In 1993, after German reunification, a team of historians and engineers tried to locate the original vault using ground-penetrating radar. They found collapsed sections, flooded chambers, and evidence of Soviet excavation. They did not find the vault. Either it had been destroyed, or it was still there, buried under 50 years of rubble and silence, waiting for someone else to need it badly enough to dig. If you've ever watched a stealth bomber carve through the sky, or seen a missile punch through a bunker on a news broadcast, or read about the hypersonic arms race and wondered where the idea came from, It came from a hole in the ground in central Germany, from a room that smelled like old paper and machine oil, from engineers who built the future in the dark because they couldn't see the present ending. Subscribe if this is the kind of history you didn't know you needed, because the next one goes deeper into the machines we thought we invented, and the people who drew them first. They built it for a war that was already over, and we've been using it ever since.